So guys, we've done multiplying. With multiplying, you could take two of them that were separate, you can multiply them together and get a single radical. So same idea a little bit, kind of, I can pull apart a fraction with multiplying, I can put them back together with the radicals, I can do all of that. Same thing with dividing. So if I have the square root of 3/4, every single time you see this, a radical over top of an entire fraction, I want you to split it. Make a radical 3 over radical 4. We're going to pretty much make two separate problems out of this, one on top, one on the bottom, and then we'll worry about simplifying and finishing it up. But anytime you have the big, giant radical, split it apart first, and then we'll see what we can simplify. Obviously, radical 3, I can't really do a factor tree on that. It's already a prime number. Square root of 4 is just 2, so the radical goes away. Okay? So big, giant radical, split that apart. So if I have, number 1, radical 16/49. First thing, split it apart. So we're going to change that into radical 16 over radical 49. So now I can do them separately. Square root of 16, that's just 4. Square root of 49 is 7. Can you simplify 4/7? I'm done. Now obviously you know they're not all going to be that easy though, right? I got to start you off easy so I don't scare you right off the start. All right, number 2, I see a big giant radical, split it apart. Radical 2 over radical 81. Do you need to go get a drink? Yeah, go ahead. All right, guys, so simplifying, once we've split, can I simplify a radical 2? Can I simplify a radical 81? What is it? That's just not. So radical 2 stays on top, I can't do anything, and then the bottom is just 9. Can I simplify a radical 2 over a 9? No. I'm done. So is it possible a radical will be left in your final answer? Yes, that happens quite often, okay? All right, so number 3. First thing, split it apart. All right, we're going to take care of the top, we'll take care of the bottom, and kind of go from there. So on the top, can you simplify radical 8? Can you do a factor tree? Let's do a factor tree on it, see if there's any pairs hiding. So 8 is 2 times 4, and then 2 times 2. Were any pairs hiding in there? Yeah, you got a pair of 2's, and then you got a single 2. Okay, so sometimes you see nice, pretty, perfect radicals that you can just tell me what the square root is, and other times you have to go back to what we've learned to do your factor tree on them. On the bottom, square root of 25, that's just 5. Can you simplify anything there? No. I got a 2 and a 5, nothing simplifies. So I'm done. All right, so first example was nice, pretty, perfect. Everything was a nice square root. Second one of them I couldn't simplify, but one of them I could. And the third one, this one I actually had to do a factor tree on, and then this number was pretty imperfect. So you kind of got some different things happening with all of these. All right, so it can't always be that easy. In math, sometimes you ever notice there's some weird rules sometimes, and you ask why, and you're like, I don't know. It's just the way it is. You just got to kind of follow the rule. This is one of those times. If I look at this problem here, radical 4 over 4/3, we're going to split that like we always do. Square root of 4 is 2. Square root of 3, I can't do anything. However, you can never leave a radical in the bottom of a fraction. It's considered not simplified. So we have to get rid of that. Okay? This whole process is called rationalizing the denominator. Honestly, I think in math, the longer and harder the words sound, the easier the concept is. Okay? Rationalizing the denominator sounds really hard and fancy, but it's really not bad. So if I look down here, here's the problem we kind of left off with, 2 over radical 3. Cannot leave a radical in the bottom. You're going to multiply top and bottom by whatever that radical is. Right? So I'm going to multiply top and bottom by radical 3. Because in essence, what is radical 3 over radical 3? It's just 1, right? If I multiply top and bottom by the same thing, they really kind of cancel out. So I'm not changing the value, I'm just changing the way it looks. 2 times radical 3 is just 2 radical 3. One's under a radical, one's not. I can't multiply them. Radical 3 times radical 3 is radical 9, and the square root of 9 is 3. Now, I want you guys to kind of get in the habit of saving yourself some time, okay? Every time we do this process, radical 3 times radical 3 end up being 3. So if I ask you what's radical 5 times radical 5, you would tell me it's radical 25, and the square root of 25 is 5. Anybody sensing a pattern here? Look at your 3's. It's the same number but without the radical. Right? Because you're turning it into a perfect square, and the square root of it is just what those numbers were to begin with. So if I ask you what's radical 7 times radical 7, you can skip a step and tell me it's just 7. What's radical 1,000 times radical 1,000? It's just 1,000. It's just a number without the radical. What's radical 7 million times radical 7 million? 7 million. Okay, save yourself some time. There's no reason to multiply them together, just take the square root and go right back to the same number. But it makes that radical disappear by doing that. All right, so let's try. So number 4, 7 over radical 5. So I don't have the big, tall radical. I don't have to split anything. Just a plain 7 on top. There's not much I can do with it. Can you simplify radical 5? Can you do a factor tree on that? No, it's a prime number. But I can't leave a radical in the bottom. So you're going to multiply top and bottom by radical 5. Right, because we can't leave that radical down there. So what is 7 times radical 5? 7 radical 5. Well, it's not a trick question. Right? One's under radical, one's not. I can't actually multiply them. And then radical 5 times radical 5 equals 5. Because technically it's radical 25, and the square root of 25 is 5. Can you simplify the 7 and the 5? No. You do always need to look for that, though. A lot of times once you've gotten rid of the radical, sometimes you can simplify those fractions that are left. All right, number 5. 6 over radical 6. Can I simplify the radical 6? Factor tree on the radical 6, what do you get? 3 and 2. Any pairs? No. So factor tree is not going to help me find any pairs. But I can't leave the radical down there. So what do we do? Good. Multiply top and bottom by radical 6. So on the top, what's 6 times radical 6? 6 radical 6. Yeah. What's radical 6 times radical 6? 6. Can you simplify? 6 over 6 is really just 1. So 1 radical 6, which is just radical 6. So just be aware. Sometimes as you kind of get going, you have to simplify the top and bottom together. Number 6. Factor tree on radical 10. Will I find any pairs? No, 10 is just 2 and 5. Factor tree on radical 3? No. All right, so I can't simplify, but I can't leave this down here, right? So we're going to multiply top and bottom by radical 3. So what's radical 10 times radical 3? Good, radical 30. Radical 3 times radical 3 is 3. Can you simplify that radical on top? Try factor tree on that. See what happens. It's 3 and 10, 2 and 5. Is there any pairs in there? No. So it actually doesn't simplify. There's no pairs. Can I divide 30 by 3? Thank you. One's a radical, one's not. I can't actually divide those. Same reason you didn't multiply them here. Same reason I can't divide them here. This is actually as far as that one goes. All right. We talked about step by step when we were simplifying with all your exponent properties. Let's kind of talk a couple steps here, because you can do these in different orders, but I'm going to try to make your life a little easier, okay? So step 1, if you have the giant radical, right, if you have that, you want to split that first. That makes sense to you guys? If you have the giant radical over the fraction, split that apart. So if you want to make a note to yourself, split the radical. And again, this is not always the case, but if you have it, you want to make sure you do that first. Then you want to simplify top and bottom. And again, these steps are all if possible. Okay? Make sure you're simplifying the top, simplify the bottom, meaning factor trees, all of that stuff. Then you want to rationalize. Rationalize your denominator. What do I mean by that? Rationalize your denominator. Yeah, good. Getting rid of that radical on the bottom, multiplying top and bottom. And then simplify again at the end. All right, my biggest thing is students have a tendency to forget step 2. They'll split that radical apart. They're like, oh, look, there's a radical on the bottom. They go to rationalize, which you can, but your numbers get huge sometimes. And it makes your job a lot harder. Okay? But if you can simplify here before you rationalize, a lot of times your numbers stay a lot smaller, a lot easier to work with. Questions so far? Awesome. Number 7. 5 radical 2 over radical 15. All right, so I don't have a big fraction to split. It's actually already split, right? Radical top, radical on the bottom. Can you simplify radical 2? No. Simplify radical 15? 15 is just 5 and 3. There's no pairs there. Okay, so then what's your next step? Rationalize it. So we're going to multiply top and bottom by radical 15. What do we end up with on the top of that? Good. 5 radical 30. Right? The radical 2, radical 15 make radical 30. On the bottom, radical 15 times radical 15 is 15. So the radical on the bottom is gone. And then can I simplify anything else? Yes. The 5 and the 15, right? They're not under radicals, so they can simplify. They can both be divided by 5. So 5 divided by 5, 15 divided by 5, 3. So really I have radical 30 over 3. Why can I not divide those? Good. One has a radical, one doesn't. Yeah. Yes, you can. If you want the one right here in front, you can keep that. Totally fine. Do you have to? No. Either way. You'll find out I'm a lazy mathematician. If I can write less, I'm going to write less. All right, number 8, radical 5/14. First step? Good. Split it apart, right? We're going to change that to radical 5 over radical 14. Okay. Next step, can you simplify radical 5? No. Radical 14? 2 and 7? No pairs. What? Wait, say that one more time. Yep. Is there any pairs? Yeah, since there's no pairs, I actually can't do anything with it, unfortunately. All right, but how do I get rid of that radical? I can't leave it on the bottom. Good. Multiply top and bottom by radical 14. Radical 5 times radical 14? Good. Radical 70 over 14. Can I do anything with radical 70? Why not? Very good. If you try a factor tree, there's no pairs. So as far as you can go. You'd think, right? A number as big as 70, you'd think there'd be some pairs in there, but there's not. Why don't you guys try number 9 on your own? Giving you guys the hardest one. All right, guys, take a look at number 9. If you follow the steps I try to lay out for you. All right, following the steps I laid out. So first thing is let's split it apart. which I think most of you did that just fine. So we did radical 27 over radical 8. What's the second step I told you most students will forget to do? Ramon? Good. He's simplifying first. That's what I said to do on step 2. So if we do a factor tree, that's 3 and 9, 3 and 3. He's fine. He's fine. So we get a pair of 3s, single 3. If we do the bottom, that also will simplify. 2 and 4, 2 and 2. So we got a pair of 2s, single 2. And again, there's different ways you could have attacked this and still ended up the same spot. All right, me personally, I like to make my numbers as small as I can. That way I don't have to do a lot of big math. All right, so I have all of this simplified, but I can't leave a radical on the bottom. So what do? Good. Multiply top and bottom by radical 2. So on the top, radical 3 times radical 2 is radical 6. So I have 3 radical 6. On the bottom, radical 2 times radical 2 is 2 times 2 is 4. Now, the other way I saw people doing, again, not wrong, I just try to avoid the bigger numbers. Some of you split this as radical 27 over radical 8, and then did exactly what I told you most students will do. You went, oh, there's a radical on the bottom, I got to get rid of it. Right? Some of you did that right away. And you multiplied. Not wrong, just your numbers got big. What's radical 27 times radical 8? Is that 216? Somebody check my math there. Over 8. And then what did you have to do? Then you had to simplify the 216. That's a lot bigger number to break down than 27 or 8. Is it wrong? No. So if I do a factor tree, that's 2 and 108, 2 and 54, 2 and 27, 3 and 9, 3 and 3. Guys, please be quiet. So you have a lot bigger factor tree. And then as you work through, I have a pair of 2s. I have a pair of 3s. And then you have a single 2 and a single 3. So that gave you 6 radical 6 all over 8. And then you had to simplify even further. 6 and 8 can both be divided by 2 to give you 3 radical 6 over 4. You get the same answer, but would you rather do all of this or just that? You'd rather do all of this? By all means, it's still a right answer. I'm just trying to help you avoid numbers that get big. Because what happens, are all your numbers going to be as small as 27 and 8? What if I give you like 500 and something on top and like 400 and something on the bottom? Your numbers are going to be huge, but if you would simplify them first, they're not as frightening. I promise. Simplify them first. All right. I'm going to give you guys a couple additional problems I did not originally put down on your notes. So flip to the back side of your notes. You got a whole blank page there. We're going to add a couple examples there. All right, so this will be considered problem 10 because we're adding on here. If I give you the square root of negative 63 over 52. You will, yeah. No, not at all. All right, guys, go back through your steps. What's the first thing I want to do with this? You want to split this. So radical negative 63 over radical 52. What did we learn on Monday about negatives under the radical? There's an I here. Yeah, there's an I on this one. So really I have I radical 63 over radical 52. Right? We can't deal with if that negative's under there. So we got to pull that I out to get rid of the negative. And then where do we go from here? Break it down. Good. Let's try to simplify the top. Because is this one that you want to multiply top and bottom by radical 52? No. I wouldn't. It's going to be huge. So let's go ahead and do our factor tree on 63. Good. 9 and 7. 9 is 3 and 3. So we got a pair of 3s. So we'll have 3I radical 7. Okay, and then factor tree on the bottom, 52. Good, 26 and 2. 26, 13 and 2. So we have a pair of 2s and a single 13. So definitely made your number smaller, right? We have a 7 and a 13 now, a lot better. Is that a good answer? Am I done? What's wrong? Good. You got to rationalize your denominator, right? We can't leave this. So I have to multiply top and bottom by radical 13. What about the 2? Do I care about him? Right. He's going to stay there. He's not the problem, right? It's that radical 13 that's the problem. All right, so on the top, we're going to have 3i radical 91. What do you get on the bottom? Good. Radical 13 times radical 13 is 13 times 2 is 26. Then I need to double check that nothing else simplifies. Can 3 and 26 both be divided by anything? The fact that there's an I there doesn't matter. But yeah, 3 doesn't go into 26, so there's nothing I can do there. 91, is that going to give me any pairs? I just came from here. 7 and 13 is the only that multiplies, so there's no pairs. That's as far as that one goes. Okay, the fact that there was an I did not hinder me from simplifying. Okay, remember I can multiply and divide with an I, doesn't matter. Okay, I can't add and subtract if it's not alike. All right, questions there? All right. What number was that? 10. So this is 11. All right, so the next one, negative radical negative 36 over, radical 48. Don't panic. Well, see, I'm giving you these examples now, so when you see them tonight on homework, you don't go, oh my gosh, Miss Solder never taught me how to do this. Yes, I did. No. They don't cancel. Say that again. It's negative I. Yeah. Yeah, because guys, right here, the first thing that you would do is take this negative and pull it out as an I. So technically, do these cancel out? No, they don't. This gives me the I. So I have a negative I radical 36 over radical 48. All right, so simplifying the top, square root of 36, that's just 6. So this is just negative 6i. Right, there's no radical because the square root of 36 is 6. If you didn't recognize that and you made your factor tree, you'd have all pairs and no singles. So nothing would go under a radical. Can you simplify radical 48? What do you multiply? 6 and 8? Okay, do your factor tree. And we definitely have some pairs in here. Pair of 2s, 4. Radical 3. That's kind of an ugly answer so far, isn't it? What's the problem with our final answer right there? There's a radical. The negatives doesn't bother me because it's not under a radical. What bothers me is that radical right there. So we have to multiply top and bottom by radical 3. So what do we get on top? Good. Negative 6i radical 3. What about the bottom? 12. Right? Radical 3 times radical 3 is 3 times 4. Very nice. And then I have to simplify. 6 and 12 can both be divided by not just 2, but 6. So what's negative 6 divided by 6? Negative 1. So negative 1 I radical 3. 12 divided by 6 is 2. And then we're done. That darn basic math, man, it kills you. What? Do you have to have the 1? No, you don't have to. You can have this negative I, radical 3. How are we feeling? Okay? I just kind of put a whole lot of your stuff we've done all into one problem there. And one last problem. You guys ready? All right, number 12. Radical negative 40 over radical negative 6. You tell me. He's hesitating. Yes. Question on the end of that, maybe? So let's go through it through our normal process and kind of see what happens. What's the easiest way to look at it? What would be the first thing you would do on the top? Let's pull out that I, right? You'd say I radical 40. What would you do to the bottom? I radical 6. So do they cancel? Yeah. You have an I on top and an I on bottom. They do cancel out. So there is no I. All right, can you simplify radical 40? So 2 and 20. She's already given me the answer. So 2 and 10. 2 and 5. All right, do our factor tree. She was correct. We're going to get 2 radical 10. So already, I think Michaela's getting faster at those. Are you guys getting better at the radicals? Doing those out, pulling those pairs? Radical 6? No, that's just radical 6. Factor tree on that. You're right, I do have to multiply it, right? I can't leave a radical on the bottom. So we're going to multiply top and bottom by radical 6. Good. 2 radical 60 over 6. All right, so we got I hear a couple things going on. So I think most of you have noticed right away the 2 and the 6 can both be divided by 2. Right, so we get 1 radical 60 over 3. Is radical 60 as simplified as it can get? Is there any pairs hiding in there? Probably. Well, 60 is 6 and 10. 2 and 3. Some of you have recognized there's a pair in there. What do we have a pair of? Yeah, there's a pair of 2's hiding in that thing. So let's take out the pair of 2's. We have singles of 3 and 5, so 15 all over 3. Can I simplify any more, or am I finally done? I'm done. Why can't I divide the 3 into the 15? Good. One's a radical, one's a not. So I'm done right there. Ooh, that one got intense. So overall, how are we feeling? Sure? Hey, okay. All right.